start? I guess I'm sharing. Okay. All I'm going to do is tell him to start and then the rest of you to discuss after this down. So my job is easy.
Okay. So this is a talk I have wanted to give for a few years, but it was deemed inappropriate until now. Inappropriate for this reason. So it's really important to understand that the following questions are not a tentative to undermine the development of support for SBML level 3. SBML level 3 is the latest official specification of SBML. SBML is the official community standard for encoding modeling in systems biology, so therefore SBML level 3 will remain so for years to come, and you have to implement support for level 3, you have to develop packages for level 3. The following questions are just meant to open discussion, because as you saw in the previous discussion, we reached a level of sophistication in SBML where we can only discuss semantics of link between SID to SIDRF to SID and so on and so forth, which make us the most sophisticated and efficient and serious XML in life science. But we don't have the general reshuffling thinking, and so this process is asymptotic and can only reach a certain level. And at some point, what happens generally in those situations, and in the past it always happened, is that you have a change of paradigm, and the former representation format, whatever, goes in the bin, and something completely new comes up. So the following presentation is meant to start a process that will avoid that, and make sure that in 15 years from now, SBML is still the community standard for encoding models in biology. Right? So, implement support for SBML level 3, right? I'm starting a process that will last years, and this hopefully not too many years, and hopefully it won't be becoming LaTeX 3 or Perl 6. So a bit of history for probably many of you actually were not here at the beginning, and there is one reason why I give this history. But so the idea of a format to exchange models in biochemistry, cell biology, started from a workshop in Visegrad in '99, and you had people there like Igor Goyanin, Pedro Mendes, and so on and so on. I was not there, to be honest. But then they decided to launch such an effort. There was a mailing list set up, and in September '99, Herbert Sorow announced on their forum that they developed a metabolic binary standard. It's not SBML, but you will see where it fits. So in '99, actually, Igor suggested why don't they use XML rather than a binary format. Meanwhile, Kitano got the Erato symbiotic funding, and he decided to launch the development of a software system in cell biology. He hired Amit Bodouri, and Amit recruited the very talented people everyone knows, and that resulted in SBML plus SBML. So what happened is that early 2000, Mike, who was already using XML in neuroscience, talked with Amit about an XML format for models in system biology. In May 2000, Herbert Sorow, who had joined the SBML team, came with a proposal that was essentially the XML version of this PMB format, and it was called MML, and that was the starting point. And after heavy modification, Mike and the other member of the team came with the first format called SBML. So the important message here is the discussion started in '99. In 2000, the first SBML format was produced. Just to give you an idea, the first recommendation of XML was published in '98. So SBML came very, very shortly after the birth of XML. And it was designed with what we knew of XML at the time. So it was developed, and you had those various levels, level 1, level 2, level 3, and you have extreme similarities between level 1, level 2, level 3. Those are the extracted from the various specification, and despite some details, basically you still have a model element, you have compartment, in the compartment you put species, and then you have reaction that transform species into other species. You have rules that allow to encode the rest of the mathematics. So essentially this is still the structure of SBML from L1 to L3. Structure that was designed then in 2000. There are differences, very, very important differences between L1, L2, L3, and the main, the commonality between all those differences is that SBML became cleaner, more generic, and more professionally designed. Basically, as we went on and we knew more about a good design of SBML XML format, and you all know that it was mirrored by an explosion of SBML support. So there are differences, but the essential structure is still the same. Now, what about level 3? The process of level 3 started in 2000, where Andrew published this document. I'm sorry, it's an internal discussion document, so I'm making my small WikiLeaks. But so this document mentioned most of the packages, almost all the packages, but they were not including actually even the control annotation. I thought I invented it. They were just not packages at the time. He envisioned to extend the core of SBML to cover everything. However, as soon as 2002, he came with the proposed structure, the mechanism of package, that remained essentially unchanged for the last 9 years. So, SBML Level 3 core is essentially a cleaned and glorified version of SBML Level 1. It's better designed, but it's the same thing. You can map all the elements, almost all the elements. And this is a compliment, because such a structure spanning 11 years shows how good it was, right? But most of those structures had been designed when we had only a couple of years experience in SBML, and even more, there were no other format around in life science, so we had really no comparison or choice between the approaches. So the questions, first question I want to ask is, would we design it the same way if we started today? From what we know of SBML, of XML, of its usage, the various software processing it, and even more important, based on what I said of my purpose today, would we design it the same way in 2020? Which is where we will be when this process I start now will reach its goal. The other thing is the first proposal of package-based structure then I showed you was proposed in April 2002. The first official release of SBML Level 3 core was October 2010. So I think it's fair to say that we need a few years if we want a new structure. So maybe not 2020, but that won't happen tomorrow. So if we never start, we will never reach the goal. Okay? So the first thing I would like to so I will present various questions, and we are not meant to answer any of those problems. The idea is to open the Pandora box so that on SBML Discuss, we can openly discuss those over the forthcoming years. The first one I want to challenge is the paradigm of one model, one SBML file, one simulation. When SBML was designed, it was designed for a very, very narrow community of people who were all doing the same kind of modeling, mostly metabolic network. And the idea was to encode everything in one file. And actually, you have to remember that SBML was actually designed as a format to exchange information between different plugins of SBW. So we had to have everything in one file. But since then, people kept, stuck on that, as you can see in procedure like description like SBML. You have one model actually. So ZML started to break that, but it's still largely the paradigm. So the idea is the corollary is that the ensemble of rules, reaction, and events are meant to lead to a system of mathematical equations solved together, right? And this is actually in the spec. There is a paragraph stating that. And this is even mirrored in Miriam. In Miriam, you have a rule, the rule 6, I think, that says a model, singular, must be instantiated in a simulation that provide meaningful results that reproduce the one published in the paper. But this is not really the case anymore in many other domains. So physiology, neurosciences, crop modeling, ecology modeling, they use different models, what we call model, at different scales analyzed using different approaches and synchronized by methods, meaning mathematics, that are described outside of those elementary models. So what they call model, a model of an ecosystem, is what we would call a set of models and simulation description, and so on. So they have a different, and Ivan actually showed example of that. And I think actually the 1-1-1 rule is also one of the reasons of the abuse of events we mentioned yesterday, I think, after Jonathan talked. So SBML is here now, ZML is here, sorry, and ZML actually allowed to run a simulation experiment using a different model. So that may change the way we want to design SBML. The idea is that an SBML file contains everything you need to describe a model is maybe not the only paradigm anymore. So that's my own project for the first 1 year, so don't copy anything. But the idea is you have various models encoded by various formats, and those are meant to describe system of equations that will be solved by different solvers. And you have you need variable transformation basically between those. Okay. So, second controversy is SBML about process description, because I actually agreed with the 3 statement Chris put on his slide when he said, well, those people say, I say it as well. Every single of your statements I agree with. And we have a problem there. So SBML directly inherits from the description of metabolic networks. I mean, it's directly originated from that, and SBML level 1 was really designed to exchange simulation model between Gepasi and Scrum. Became Kopasi and Jarnac. And successfully so. I mean, I'm not criticizing. That was the only way to go. So the paradigm is chemical kinetics, right? With processes consuming pools and producing pools. And the ODEs or the quantities are emerging from that. So is SBML about process description only? If the answer is yes, why do we try to stretch it to cover rule-based models, logical models, statistical models, and so on and so forth? If the answer is no, why are the elements necessary to the description of processes in the core? Why do we force people doing rule-based models, logical models, statistical models to understand process description while they don't need so? But in my opinion, there is an inconsistency here for the future. The other thing is, so third controversy, one language or federation of languages, and it ties, of course, to the previous slide. Some model approaches are not meant to be used together, meaning in the same given system of equations. They are meant to be used on their own, sometimes connected through the result of one simulation that inform another model, but they are not meant to be used together and solved with a given solver. So for instance, and we have 2 examples of the problem it causes to try to encompass everything at the same time, and the 2 examples are at the opposite side of the field. The multi-package, for the multi-package we encountered a lot of difficulties, and the resulting packages are going to be very complex, because rule-based modeling is not supposed to be used with process description. Rule-based systems like BioNetGen, Kappa, and so on are meant to describe rules that will generate model description, process description down the line. And trying to put them together is extremely difficult. created something, a big success is the quality package, described by Claudine yesterday. And the quality package is very simple because there's no point of contact between quality and core classes. Because in logical description, there are no processes. And so, no need of merging both. And you can't, at the moment, there is not a single software that will run qualitative modeling at the same time than chemical kinetics. You have different software, and then you combine them in some way. In logical approach, in qualitative approach, you don't have the notion of time, except as ticks sometimes. But even that is you collapse all the ticks if you don't have even. So those are two examples that maybe point to a problem. So the other thing is that the communities using those models are almost not overlapping. We are very lucky to have Claudine here. We have Michael here. Michael, are you still here? Yes. But by mostly at the moment we kind of fail to gather the community at large in our community. Maybe because there is some lack of common needs. So, I mean, we model, the various communities model different aspects of biology, right? Have different questions. Therefore, there are different meetings, different journals, they versus us. So we have to do. Yeah, I know you.
Do you want discussion or
no, not yet.
Okay.
Not yet, but there will be. But
I disagree with some statements here.
Sure, but I mean, I happen to know the qualitative community very, very well for personal reason, and I mean, they have their own meeting format and everything. And the rule-based community even published papers saying the rule-based modeling community says and proposing. So I don't say I'm against the versus us, of course. The only thing I want to say on this slide is that maybe it should be more sensible to have different representation in different SBML sublanguages. Or at least in different model elements, rather than to try to put them together. So a model element is meant to generate a system of mathematical representation, and those will be different. In SBGN, we decided to go with different languages, and SBGN PD correspond to SBML core, SBGN AF correspond to logical modeling, SBML EOR correspond to rule-based modeling. And we forbid hybrid representation. So anyway, the package system will still be used for different aspects of the same approach. It's clear that the spatial package comes together naturally with the process description. Those processes become spatial. So I said there were external initial conditions. So one of the main initial aim of SBML, remember, was to exchange information between plugins. So everything had to go in one file that contained the initial representation. But already, I remember in the first meetings, they were grumbling about that. Because, for instance, the virtual cell group, and we did the same with the first version of Stocksim, what we called model was not an SBML model. An SBML model is an instance of a model. And the numbers are not part of the model, and Yvonne actually presented that for 9ML as well. So, and in pharmacometrics, PKPD, this is the same thing. Numbers are outside, you have the data, and you have the model. Models are mathematical equations, no numbers. So externalizing those numbers would allow us to reuse the same model with different parameterization, and we could handle numbers in a much more homogeneous manner across the whole life cycle of a model, rather than having numbers in SBML and numbers in SLML and numbers in SBML, new ML. And this one, you know, modularity in core. So biology is modular, despite what Lucien says. An enzyme has one point of output, the catalytic activity, may have several inputs, but then the same for every structure. And at the moment, so that's one point. At the moment, modelers have to edit entire SBML files, and this is a big hassle. For super large model, the Jamboree model, we couldn't distribute the handling of SBML, so those Jamboree were actually handled by Excel files, right? And Niels Franson generated the SBML afterwards. So do we want to push people to use Excel files? That's their visualization is very, very difficult. So in SVGN now we have submaps for process description, but we can't use them to represent SBML models. And we even have groups now. And talk to Alice Villager. She was supposed to develop software to represent the Jamboree models, and basically she couldn't really. Sorry, the Jamboree models are the gold standard representation of metabolic networks, like the one we published in 2008 on yeast, and we just submitted the human. So the human one has 4,500 reactions. So another thing is development of those models may require the expertise of workforce of many groups. It's much easier if we can distribute the modules. Problem of multi-scale models, of course, meant to be simulated in adversarial software that may tie to that. Modularity allows robust encapsulation and reuse. And many computer representation formats are modular, most of them. It's just weird that in SBML we have one file that contains everything and one model element that contains everything. And one set of units that is the same for every single species and context. So we actually considered cell element structure as a solution back in 2000 when Amit came to see the various groups. He mentioned the cell element, and we printed out. We had this booklet from Physium Science, but it was deemed too complicated. It's hard to develop partial support for such a system. Either you develop completely or not. But alternative were proposed. So a group that was part of the SBML community and left it was the group developing Promotiva, that was a modular system of simulation. And so the urgent need at the time was a simple format to encode metabolic models, and it was great, and that was the way to go. But now, 11 years down the line, maybe we should think about it. And the CellML approach, it may be the right one from an engineering point of view, and we could maybe do that better now. And so, yeah, I mentioned unit, and there is no really complexity increase because the current L3 core would just be a default group. And this is not the comp package. This is not the comp package. You can emulate modularity with the comp package. Comp package is reusing existing model, and you have all the problem of replacement of encapsulation in modules is different. Anyway, so the hardcore controversy are past. I will drill down to sim. I want to cool down before you throw tomatoes at the end.
Do you think that your idea of that sort of modularity, is that the sort of thing you could do with X-include off the shelf?
No, it's not X-include.
I mean, it's not just copy and paste.
But you can. Stefan proposed an X-include where you could include everything everywhere. You don't have encapsulation and it's
so it's not the copy and paste of X-include. It's something else.
No.
Okay.
It's developing proper modules with it's object-oriented description of language of models. Okay, attributes versus elements. So SBML doesn't use XML element with content, except the map, the ML, but it comes from MapML. For SBML per se, when we have properties, we use the value attributes to the value. So this is a species, right? It has an ID, a compartment, initial amount, and then a unit, and then annotation. The annotation is linked. The description, the audio description here, link that should be X. Sorry, that's a copy paste error. Link to the meta ID of the element. So we have several problems with that. So storing alternative values is not possible. You need to have, I don't know actually, that will be part of the distrib package. Again, you just can't store alternative values of anything. Relating the attributes is difficult. So here you have an element, a species, and you have compartment, initial element, units. You can have plenty of other attributes. We could add others. And unit of what exactly? So all that is hidden in the spec, in the SBML spec. This is why semanticians have problem with SBML because you have to read the spec, and a lot of the knowledge is implicit or is explicit in the spec, but it's not explicit in the XML. So having elements will allow us to have a higher granularity. Species could have something called initial amount with a value and a unit, for instance. Annotation cannot easily point to attributes. So this one, here, this is an annotation to a PubMed, an entry in PubMed, right? So I say that this element is described by this piece of literature. What exactly is described? Do we describe the fact that this species is located in this compartment? Do we describe that the initial, the amount of this species is this value? We don't really know what we can't. So there is a system in the anode package based on a complex system of subclassing, but it's basically the point is that this piece or folio is within the species. Right. And now I'm finished with the big issue. I have just a list of small things we can think about. Again, I want to expand the map. Examples are vector, matrix, sum, product, but there are others. So how do we do that? Do we do a package, extend map or something? Semantically loaded name, one of the biggest hindrance to adoption of SBML in the not outside or narrow community, of great bubbling narrow community, is the fact that the name of element in SBML are semantically loaded. So we call processes reaction, even if we want to represent all processes really, particularly in L3 now we have relax. So not just biochemical reaction. We already represent very often transport, but even reaction between cells that produce cells. So those are not really reactions, they are processes. And if you talk to people outside, they say, oh, but SBML is for biochemical reactions. Species, same. They are pools, really. So first of all, they are not all molecular species. They can be many things. As soon as you can have a certain number of things that are undistinguishable as far as the model is concerned, you can put them there. But in addition, there is a confusion with organism, which is something every time I talk about SBML, someone doesn't have to explain, no, species is not Homo sapiens. So, anyway. And to be fair, the semantics should be exported as much as possible to proper tools for semantics, and those proper tools are ontologies and the tool used to it, which has the added value that you can then have an independent evolution, pace of evolution of these semantics. Explicitly defined pointers, that was briefly introduced in Gothenburg and then removed again, but at the moment, everything is in the spec and in libSBML to know what point to what, and we have several namespaces, and there are mechanisms in XML to do that, using, for instance, X pointers. No density, everything expressed in amount, so that will have to tie with the spatial. I'm not sure it's the right way to go, but at the moment in the core, we could do it, and that will not change anything. Every species must be in a compartment. We can't have species within compartments, so basically we have the size, and so we could right now express everything in as numbers. Do we want that or not? I don't know. Make time an explicit variable. At the moment it's implicit, you have the C symbol if you want to use it in a math, but if you want to use SBML within ZML, for instance, we had to create our own C symbol time and say that, oh, by the way, this is the same than SBML 1. But in a system of variable, ZML does it in time is just one variable. The fact that it's blessed and you have a partial differential equation dx over dt is just, and if we go to more complex model representation with gradient and so on, it's just a variable among others. And if you want to go to hybrid system with different model representation, in addition there will be many times per model.
Can I say one quick thing?
Sure.
Maybe one attribute of these species might be its concentration, which is a variable that you could use. Another one could be the amount, which is a variable that you can use.
Sure. Yeah. Okay, finally, so I'm finished. Do we want to cover all that? remember this figure I presented on the first day? All those modeling in biology. And so do we want to cover all that? And if we want to cover all that, will we be able to cover all that without adapting to them? That was the question. So I would like to finish on that. A note on them versus us. The SBML community, and more largely combined now, is not defined a priori, right, or should not. But it grows out of the needs for encoding models. And it's been the case since day one. So SBML is a format to exchange models between different tools. So that's the first thing. When we started, Amit Bouluri came, gathered people, and you know, we were 7 groups initially. Look at us. And many people were not there at the time because we didn't know about their need of encoding those models. I mean, rule-based model. People, I think Michael joined in 2004, Claudine in 2002 in Alfield. I mean, progressively people joined. So the other thing is SBML is a format to exchange models between tools. So if we want to cover a new type of model, the developers of the tool that will exchange these models must be involved, right? Because they know better what to cover, and they know how they do it at the moment. We all think we're really clever and we know everything. The truth is we know a very tiny bit of the modeling environment. And that, because we are the expert of that, and we have a peripheral knowledge that comes from readings and courses, but we are not experts. That's the first thing. The second thing is that academic people will not use a format that is imposed from outside. That may work for industry, that will not work in academia, ever. And finally, the third bullet point on them versus us is that the most experienced member of the community must guide, in my opinion, and help the newcomers. Well, we should always try to get new expertise on board, always. We do not know better what people want or need, but we can help them realizing what they want or need. But we don't know. I do not develop multicellular models. We need to get people developing multicellular models if we want to cover multicellular models. That's just one tiny example. We have all those kind of models. That's it. So we have now 9 years to discuss all those issues.